Hello everyone, welcome to my YouTube channel Decoders Den. Hope all of you are doing good. So today we are going to see what is SOP and POS. SOP and POS, these are nothing but the way of representing the Boolean expressions. Okay, these are the different ways of representing the Boolean expression. Okay, first of all we are going to see SOP. SOP is nothing but sum of product. The way of representing the Boolean expression for the output high. The way of representing the Boolean expression for output high means the expression for which return the output which is going to give high, right? So the next comes the each product terms is known as min terms. SOP, sum of products, is going to be the sum of multiple product terms. The product terms which are going to be there into the expression, each term is going to be known as min term, right? So each term is going to be known as min term. So this is a term which is going to be used infrequently. Okay. Next comes the variable which are having high value can be represented in non-complemented form. So here comes, okay. So we are going to see one example for this also. So what this statement says, the variables which are having high value can be represented in non-complemented form. Let's take one example, okay. Suppose there is variable like a, b, and suppose y is the output, okay. Y is a function of a and b. 0 0 for which y is going to be 1, 1 0 for y is going to be 1 again, okay. We are going to consider only SOP term. 0 1 y is going to be 1. So this is the expression, and that we need to represent in terms of Boolean expression, right? Okay. So what our third point says, the variables which are having high value can be represented in non-complemented form, okay. So these are the variables on the basis of which y is going to be considered. So okay, so see over here, the what is the state of a is here low, right? So this is represented in complemented form. The fourth point is says that the variables which are having low value is represented in complemented form. So considering these two expression, we are going to write the Boolean expression for this truth table. See over here, y is high for when a is equal to 0, b equal to 0, means y is a function of a comma b. This is high for a is equal to 0, b equal to 0, means it is represented in terms of complemented. Why? The value of a is 0, b is 0. A is 0, b is 0. That means complementary. That is a product. This is one product term that we got. This is also known as min term. Next, sum of product. Sum of product means addition has to be there, right? Next term comes a is high, b is low. So a is high, it is high, that's why it is written in non-complemented form. B is 0, means it is low, this is written in complemented form, plus, okay. Next comes a is 0, b is 1. A is 0, b is 1. So a is written in terms of complement, b is written in non-complemented form. So this is the expression for this truth table. Hope you got this, okay. So if you want to represent the SOP expression in terms of numbers, right? Usually it is to be in terms of numbers as well as the expression in variables, okay. So suppose if you want to represent like 1 2 3 5 7, suppose there is one expression which is a function of three variables. Suppose it is a function of x, y, z, okay. So how this can be represented? This can be represented by summation of m. This is one kind of symbol which says that these are the sum of product term, SOP terms. Means these are the min terms for which the output is going to be high. This is what this whole thing is going to be signifies. Okay, hope you got SOP. Next we are going to see POS. So POS stands for product of sum. Okay, this is another way of representing the Boolean expression for the low output. The expression is going to be represented for low output variables. Okay, so each sum term is known as max term. As we have seen in SOP, each product term is considered as min term. Here we are considering it as max term. So this is a important max term. Okay, next, the variable which are having high value represented by complemented form, and the variables which are having low value represented by non-complemented form. So here we are going to see one example for these 2 points. Okay, let's take same variables like a, b and y. Y is the output. Suppose for a equal to 0, 1, it is 0, 1, 0, it is 1, 0, sorry. For a equal to 1, b equal to 1, it is again 0. So what is POS? POS stands for product of sum. That means we are going to do product of the terms which are there in our sum expression. Okay, so see over here. By concentrating these 2 points, okay, the whatever the variables is present in low state, that is represented in non-complemented form, and the variable which is present in high state is going to be represented in complemented form, and in between those we are going to write plus operation, that is going to represent your sum. Okay, so let's write the expression for this truth table. This can be written as a. Why a? A is at low, and low is represented by non-complemented. Plus should be there. B is 1. This is represented by B bar. It is unlike in SOP. In SOP, what we are writing? For 0, we are writing bar, and for 1, we are writing non-bar, right? It is normal. Next, take it into the bracket. Next, product. Okay. Next comes a bar, right? A bar plus b. Okay, hope you got this. A bar plus b dot a bar plus b bar. So this is an expression for y, which is function of a and b. Hope you got this. As we have seen in our SOP, so we are going to see if the Boolean expression is given in terms of number for which the output is low. Okay, that can be represented as, suppose y is a function of x comma y comma z. That means we are going to get 8 terms, out of which some of the terms will be low, some of the combination for which output is going to be low. So those combination can be represented by pi of m. Pi of this is capital M. Okay, pi of m equal to, suppose 2, 4, 5 and 7. So these are the terms for which the output is going to be low. Okay, so this is how it is going to be represented. Okay, next we are going to see one of the example for which we are going to write the min term and max term. That means we are going to write POS form and SOP form. So one example, if you want you can try for it. So we'll see first first of all SOP, okay, that is sum of product. SOP, what SOP says, is going to represent the expression for the terms which is giving high output. So see over here, y is a function of a, b, c. Y is a function of a, comma b, comma c. For which are the terms it is going to represent a summation of m. For which term it is going to be high? See over here, this is nothing but 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7. For which are the terms it is high? For 0, right? It is high. For 2, 0. For 2, for 3 and 5. Okay, so we have written over here, for these are the terms the y is high. So how this can be written in terms of your a, b, c variable? Okay, so see over here, for 0, okay, for 0 it is going to be represented as, for 0 it is a bar, b bar, c bar. Okay, for 0 it is going to be a bar, b bar, c bar. For 2 it is going to be a bar, b, c bar. For 3 it is going to be a bar, b, c. And for 5 it is a, b bar, c. So here a, b, c are the variables where a is a MSB and c is a LSB. Okay, so if you convert this into the number boolean, binary, it will be represented 0, 0, 0, that means 0, 0, 1, 0, that means 2. This will be 0, 1, 1, 3, 1, 0, 1, that is 5. Okay, this is how this whole truth table is written in terms of SOP. Next come to the POS. Okay, we'll see POS, that is nothing but product of sum. Okay, so the same truth table can be written in terms of POS. So y is a function of a, b, c. So we are going to see which are the terms for which our output is low. Okay, so go to the truth table, see over here, the term 1, for which our output is low, the term 4, right, 6 and 7, 1, 4, 6, 7, 1, 4, 6, 7. Okay, 1, 4, 6, 7. You can see over here which are the terms were included into the SOP expression. Those are not there at all. Okay, so we can see that the terms are totally different. Okay, they are not, there is no any intersection between these two expression. You can see over here. Okay, so how this can be written in terms of POS form? As we are known, the variable which are having low, those are represented in non-complemented form. The which are having value as high, those are represented in complemented form. See over here. First of all, 0. For 0, a is 0, b is for 1, a is 0, b is 0, c is 1. That means a plus b plus c bar. Okay, a plus b plus c bar. This is a plus b plus c bar. So this is a one sum term we got. Next come 4. For 4 it will be, let's see over here, a bar plus b plus c, a bar plus b plus c. Okay, a bar plus b plus c. Next comes 6. For 6 it will be a bar plus b bar plus c. Okay, a bar plus B bar plus C. Next comes 7. 7 is going to be A bar plus B bar plus C bar. It is going to be A bar plus B bar plus C bar. So this is the POS expression we got for the truth table. So these are the two ways through which we can represent the whole truth table. Okay, hope you got this. If you are having any doubt related to this, you can post it into the comment section. Thank you for watching.